Hit the system once, one spike, one instant, then nothing. Whatever comes back out, you now know everything that system will ever do. Every input, every signal, forever. From one single experiment. That's not an exaggeration, and the operation that cashes it in is convolution. It's question 2 on your paper almost every year, and it's 5 marks. So let's take the exact one they keep asking and never get it wrong again. Here's the system. Feed it a single unit impulse at n equals 0. What comes out is called the impulse response, h of n. For our question, h of n is a half to the n, but only for the first 3 samples. So h is 1, then a half, then a quarter. Then it stops. Now here's the trick that makes the whole thing work. Take any input signal and stop seeing it as a wave. See it as a stack of impulses instead. One spike per sample, each with its own height. Our input is 2, 1, a half, minus 1. That's 4 spikes. The system is linear, so scaling the input scales the output. And it's time invariant, so delaying the input just delays the output. Put those two together, and you get the whole answer. Each input spike produces a copy of h, scaled by that spike, shifted to that spike. 4 spikes in, so 4 scaled copies of h come out. And then they just add up wherever they overlap. That's convolution. Write it down. Y of n equals the sum over k of x of k times h of n minus k. Look at that h of n minus k. The minus k is what flips it around. That's the flip everyone memorizes without knowing why. It's not a rule someone invented. It falls out of asking which input at which earlier time is still contributing right now. So, the exam method. Flip h, slide it across x, and multiply overlapping samples. At n equals 0, only one pair overlaps. 2 times 1. Y of 0 is 2. That's the first output sample. Slide by 1. Now 2 pairs overlap, 1 times 1, and 2 times a half. 1 plus 1 is 2. Y of 1 is 2. Slide again. 3 overlap now, a half plus a half plus a half. Y of 2 is 1.5. That's the peak of this output. Next, minus 1 times 1, plus a half times a half, plus 1 times a quarter. Minus 1, plus a quarter, plus a quarter. Y of 3 is minus 0.5. Keep going. Minus 1 times a half, plus a half times a quarter. That's minus 0.375. And the last one, minus 1 times a quarter, minus 0.25. There it is. 2, 2, 1.5, minus 0.5, minus 0.375, minus 0.25. 6 numbers. And now, 3 checks that catch almost every mistake you'd make. Check 1, the length. 4 samples in, 3 in h, so 4 plus 3 minus 1. 6. If your answer isn't 6 long, you've dropped a term. Check 2, the endpoints. The first output is always the first x times the first h. And the last output is always the last times the last. Minus 1 times a quarter. Check 3, and this is the one nobody uses. Add everything up. The sum of y always equals the sum of x times the sum of h. Our x sums to 2.5. Our h sums to 1.75. Multiply those, 4.375. And our 6 outputs sum to exactly that. 3 checks, about 15 seconds, and you know the marks are safe. 1 spike, 1 measurement, and the machine has no secrets left. Everything it will ever do to anything is already written in that one answer.